Bismillah, this is Dr. Magda Talib Al-Hinai from the Department of Mathematics and Statistics, Sultan Qaboos University, presenting Quadratic Functions. This presentation is exclusive for the Independent Learning Center. We start the presentation discussing the graph of quadratic functions. Suppose we have a quadratic function of the form f of x equals ax squared plus bx plus c, where, of course, a is not equal to 0. The graph of any quadratic function is known to be a parabola. Parabolas usually are U-shaped, and in our case for the f of x, we either have this U-shape open upwards or open downwards. This depends on the coefficient of the leading term, a. So, if we have the leading coefficient, meaning the coefficient of x squared positive, the parabola will be open upwards, as we see on the figure to the left-hand side. The vertex in this case, or sometimes it's called the turning point, is the lowest point in the graph. So, if we look at the graph to the left-hand side, where a is greater than 0, we have a parabola that is open upwards. The vertex is the lowest point, and at this vertex, the function has, of course, a minimum value. Meanwhile, if a is less than 0, this is the case to the right-hand side. In other words, if the leading coefficient is negative, the parabola is open downwards, and the vertex in this case will be the highest point. So, at the vertex, the function has a maximum value. The vertex of a parabola is the point whose coordinates are h and k. h equals minus b over 2a, while k is equal to f of h, which is f of minus b over 2a. And as we said, for a greater than 0, the parabola has a minimum value, f minimum equals f of h. And for a less than 0, the parabola has a maximum value. F maximum equals f of h, which is f of minus b over 2a. So let's have an example. Find the coordinates of the vertex of the parabola f of x equals x squared minus 2x minus 3. Here, a, which is the coefficient of x squared, is 1. b, which is the coefficient of x, is minus 2. So h, which is equal to minus b over 2a, is equal to minus 2 over 2 times 1, which is minus is plus. So we get 2 over 2, which is 1. So the x coordinate for the vertex, which is h, is equal to 1. Now for k is equal to f of h, which is f of 1. We substitute for 1 in the given function. We get 1 squared minus 2 times 1 minus 3. We do the addition and the subtraction. We get f of 1 equals to minus 4. Therefore, the vertex of the parabola is the point 1 and minus 4. Another example. Find the extreme values of the quadratic function f of x equals minus 2x squared minus 12x minus 3. So here we note that the leading coefficient a equals minus 2, which is less than 0. Thus, the parabola representing this function is open downwards, meaning the vertex is the highest point, and accordingly the extreme value is a maximum. So we have f maximum is equal to f of minus b over 2a, which is equal to f of minus. What is b? As we see in front of us, b is the coefficient of x, and it is minus 12 over 2 times a, which is minus 2. So here we have 3 minuses, minus in the beginning and minus in the numerator, and a third minus in the denominator. Minus in the beginning, minus with the 12, and minus next to the 2. So this is giving us f of minus 12 over 4, which is f of minus 3. We take this minus 3 and we plug it in the given function. So we have f of minus 3 equals minus 2 times minus 3 all squared minus 12 times minus 3 minus 3. We do the addition and the subtraction, we get that f of minus 3 is equal to 15. So the maximum value of the function is 15. Here comes another example, asking to find the extreme values of the quadratic function f of x equals 3x squared minus 6x plus 1. We start looking at the leading coefficient. The leading coefficient here is 3. 3 is greater than 0. And a positive leading coefficient means that the parabola is open. Yes, open upwards, meaning that the vertex is the lowest point, and accordingly the function has a minimum at the vertex. Now we need to find this minimum value. So f minimum is equal to f of minus b over 2a, which is equal to f of minus. For b we substitute minus 6 over 2. For a we substitute 3. So we get f of minus 6 over 6. Minus 6 means plus 6. So we get f of 6 over 6, which is f of 1. We take this 1 and we plug it in the original function. So 3 times 1 squared minus 6 times 1 plus 1. This is equal to minus 2. So the minimum value is minus 2. Now let's present the standard form of equations of parabolas. We start with y equals ax squared plus bx plus c, where a, of course, is not equal to 0. This equation can be rewritten in its standard form, which is y equals a multiplied by x minus h all squared plus k. We start by the y equals ax squared plus bx plus c. And we take a as a common factor. As we see in front of us, I write the a in the red color. So we have y equals a open bracket x squared plus b over a x. So we're taking a common factor only from the first two terms, plus c. Now we add and subtract the square of half the coefficient of x. So what's the coefficient of x? Yes, it's b over a. What's half the coefficient of x? It is half b over a. So we want to add and subtract the square of half the coefficient of x. We do this in order to be able to complete the square. So look at the first three terms, x squared plus b over ax plus b squared over 4a squared. This is a perfect square, and I write it in blue. So the first three terms will be rewritten as a perfect square. So y equals a, open a black bracket, and then inside it we have the perfect square, which is written in blue, x plus b over 2a all squared, minus half b over a all squared. I close the black bracket and then we write plus c as it is. Now we have y equals a into x plus b over 2a all squared plus c minus b squared over 4a. If we compare this with the standard equation of the parabola, y equals a into x minus h all squared plus k, we arrive at h equals minus b over 2a, and this is written in purple because we compare purple to purple as we see in the above two equations, and k equals c minus b squared over 4a, and this is written in blue as we compare blue to blue in the last two equations. These two forms of h and k can be used also to find the coordinates of the vertex of the parabola. Now let's have an example. Express the function f of x equals x squared minus 2x minus 3 in the standard form. Use the transformations of functions to sketch the given function. Now, as we see from the given function, we find that a equals 1 and b, yes, minus 2. c is minus 3. According to the formulas which we got in the previous slide, h equals minus b over 2a. And substituting for minus b and a, we arrived at h equals 1. Also, k equals c minus b squared over 4a. This is equal to minus 3 minus 2 squared over 4 times 1. This equals minus 4. So here we got the h to be 1 and the k to be minus 4. Therefore, the standard form for the given parabola is y equals a, which is 1, multiplied by x minus h all squared. H is also 1, plus k, which is minus 4. I read it again. Y equals x minus 1 all squared minus 4. So this parabola is open upwards, and the curve of which is given in front of us in the figure. We have y equals x minus 1 all squared minus 4. As we know, the x minus 1 all squared gives us a horizontal shift to the right hand side by 1 unit. The minus 4 gives us a vertical shift downwards by 4 points. So that's why we have the graph as we see it in front of us, shifted 1 unit to the right and 4 units downwards.